Hi guys! Today we have a face recognition project. We're going to build a neural network from scratch that would be able to recognize a couple of celebrities. In our end result, we should be able to pull most images for these celebrities. The neural network should be able to recognize them. So here are a couple of examples. The neural network does a fine job to recognize the celebrities. This tutorial will be divided in 3 different parts, and if you have any question, just leave it in the comments. Hope you enjoy it. Okay, we're going to use a dataset called Celebrity Face Recognition, and the dataset has around 800k images of 1100 celebrities. So each celebrity has 7 to 800 images, and this is a huge dataset. Thankfully for us, it's split in 12. So for this little project, we're only going to use part 1. So go ahead and download part 1. After your download is completed, you'll find inside dir001 a lot of subfolders with celebrity names. So our photos are inside of the folders. So let's take 5 celebrities: Adam Sandler, Adele, Andy Samberg. Where is Andy? I guess we already passed it. Yes, Andy. Arnold Schwarzenegger, and Ben Stiller. And let's extract it somewhere. Here we go. This may take a while. It's around 14 gigas, so it's a lot of information. Okay, and now we can pick inside the folders. So in Adam Sandler, we have a lot of pictures of Adam actually, right? But you can see right away that some pictures are not that good, right? Doesn't look like Adam. And here Adam is a bit large, right? So we have to take care of that, but not right away. Before that, let's actually organize our folder and let's create a folder for the full dataset. And let's put everything inside it. Let's also create a folder for training and a folder for validation. Cool. Now the next step is actually to get a notebook and start to do some stuff. So let's start by the imports. Let's import Tensorflow, STF, classic one. Let's import NumPy as np, import matplotlib.pyplot as plt, another classic, and let's import OS. Okay. Now that we have that, let's start from getting some variables. We don't want to write the paths all over again, so we have our path. We call it full dataset, training and validation. So let's have it here. Full dataset. Let's have the training path. It's just training and validation path. And again, just validation. Have it. And now let's have like the celebrity names, right? So let's just call it cell and list dir of our path folder. This will give us everything that is inside our folder, and that means the name of the 5 folders and our celebrities. Cool. So let's move on. The next thing is if we go back to our pictures, we can see that we have not only face pictures, but we have a lot of bodies. So besides the incorrect images, we also have like bodies, right? Our goal today is just to build a simple neural network that recognizes faces, not the full body. So we're going to use a small trick from CV2 that will help us to collect only our faces and nothing else. Let's go back to our notebook once again. And to help us with that trick, we actually need like an external XML file. Okay, I will provide this XML link in the description below, and you'll find it in the GitHub page, probably in the GitHub, not in the description. So let's just take it. So I'll paste it here, and here we go. We have our XML link, and we're going to get it with a double get, and we want to pass the URL here and save it in this folder, right? Not very necessary, but let's do it. We go back to the folder, we can see that now we have an XML file, our main folder, and this XML file will help us to get just the faces. So let's do just that, and get another import, CV2. We're going to use the cascade classifier from CV2. So let's give it a variable name, face cascade, and let's just take cv2.cascade classifier. And here we are going to have our path of the XML file that we just downloaded. If everything goes well, you'll not see any error messages, so let's hope not. And let's now create a function that opens the pictures. Let's take one example. And inside the picture, this function is going to look for a face. And it's going to trim the face out, right? So we're going to have a new picture with just the face. So we're going to crop the picture. So let's do just that. So let's call it get crop it or whatever, just name it something. We want to have an input of the path, size, the scale. Let's leave a scale of 1.3 by default. Okay, so the next thing is actually to get all the images from the path that we are passing here on the function. So let's have some list comprehension here, and let's say image for image in os.list dir and our path we're going to provide. And of course, if the image ends with .jpg. So we don't want to get any wrong formats on the images side. So now that we have the images, let's have like a main loop, and we can just call it image name in images. And we're going to start by joining the main path and the image that we're getting here from this list. So we basically just want the absolute path for the picture, right? So let's do just that. So image name equals to os path join. Here we're going to join the path and the image name. Maybe name, not the name. Okay, now that we have that, we can start by reading the image. There are a couple of ways that we could do that, but since we are using CV2, we are like just using CV2. So let's just use the em read from CV2, and let's pass the image name. So this will read the image. And the next step is actually to get like the face separated from the rest, right? We're going to get an array faces, and we are going to use our variable face cascade, and we want to detect multiscale. Multiscale, yeah, line one. Okay, we're going to pass our image, and we want a scale factor of 1.3. We have the variable here, I guess, so like that. And that's everything. You can play with the scale factor. You can see that the face gets bigger or smaller depending on the factor that you are using, and you can even like not have a face at all if you have the too big value. So the next thing is like to check if there are any faces. So the output of this method on our face cascade that comes from the cascade classifier is an array with a location of the face in the picture. So this will give us the x and the y, and we can get like our faces. So let's take just a quick sanity check. If the faces is equal to 0, meaning there's like no faces here, we want to remove that picture from our folder because that's not a good picture, or there are no faces. We are going to lose some good information, but mainly we are going to get rid of some bad information too. Okay? So if we find some faces, now we want to do something. So again, these faces has 4 values. It has the x, the y, the width, and the height. Okay, so we can say that for, and here is like we are going to decompress our array here, age and height. So faces. We are going to have a new image, and this new image will be just a resize of our image. And here, since it's not y0 and y1, we have to actually get the y until the y plus the height, right? To cover like the entire rectangle. And we also want the same for x, so x plus the width. And this will get us like a nice rectangle around the face. So we also want to pass like a size, and this size comes from here. We'll have like a predefined size that we are going to use in our model. It's going to be 175 by 175. I tried several sizes. This was the one that actually worked the best. And we also can have some interpolation. This will make our faces a bit better. So we want inter area. I think it's capitalized. Let's check the IntelliSense. Yes, it is. And inter area. And that's everything. So we have a new image, and this new image is just a face. Okay, instead of having all the other information that we don't want to input in our model. So let's just save it. So em right, let's the image name, want to keep the exact same name, and new image. So this is going to delete our bad images, or almost all the bad images, and it's going to transform the good ones in just the face. Okay, let's try it out. This is just a function, we still have to call it. So we want to call it for all the celebrities. So for C in S list here. We actually already have it here, so we can use the variable right away. We are going to call this function, and we're going to pass. We have to join again with the absolute path. So path.join, and here we're going to pass the path, and we want to pass the CE. Okay, so let's also pass the size of the image, and we don't have to pass like a scale, we can use the default one, so that's fine. Let's just call the function and see if it works. And it seems it's working. It's going to take a while because there are a lot of images in our folders, but it's eventually going to work. So let's just wait a bit and see the results. Okay, it seems it's finally finished. And now we can see that we have faces instead of full bodies, right? It looks way better, and it will be way easier for the neural network to understand who is the celebrity. Okay, So, but you can still see that there are some wrong images. This is not Adam. This is not Adam either. And it doesn't look Adam again, right? So thankfully for you, I did my homework and I cleaned a bit the dataset. It's not perfect, but it's slightly better. So to help us out, we have to go to the GitHub link on the description and we have to extract the two files there, train.csv and validation.csv. So these two files only have the name of the celebrity and the number of the good images. So we are going to use it to clean the folders and it's going to be helpful. You will see. So just stay tuned, we are going to do it on part 2 of this tutorial and we are going to move things around. We're going to move images from the full dataset and we are going to split it between train and validation. So just stay tuned and watch the next video.